Drones pose new challenges for security managers worldwide, because traditional security measures are completely ineffective against them. Drones are fast, small and discreet. They come in many forms, and there's new drone models constantly being introduced to the market. Founded in 2014, D-Drone has developed a market-leading system for the detection of and defense against civilian drones. We follow a multi-sensor approach, combining our own sensors and sensors from leading manufacturers that are connected via the intelligent drone tracker software. Together, they create a reliable detection system. The sensor network can be expanded as needed for the individual installation. The basis for the detection starts with the foundational RF sensors from D-Drone. They detect, classify and locate drones in real time by listening to radio frequency. For optical detection and preservation of evidence, we integrate high-performance cameras from selected partners. In many cases, high-performance cameras provide identification of the drone's payload. If needed, we can integrate special radar systems to detect autonomous drones. Thanks to the intelligent drone tracker software, this combined and layered sensor approach will occur automatically and provide drone recognition. If there is danger to the area and an organization has authorization, jammers can be integrated to the solution and will stop the drones. The D-Drone system generates valuable data about drone activity in monitored airspace. On which days and times do most drones enter? What kind of drones are they? Where do the drones come from and where are they going? The Airspace Security Report helps our clients understand the activity in their airspace. And with this knowledge, they can develop effective action plans. The more you know about drones in your airspace, the better you can protect yourself. Best before something happens.
Worldwide demand for fast and flexible delivery of goods is forcing logistics to adapt. The need for airport infrastructure prevents cargo aircraft from delivering directly to the customer. In addition, just-in-time logistics is hampered by traffic jams and poor road conditions. We have a vision for the future where cargo can be delivered rapidly to any location, near or far. Recent advances in electric powertrain, machine perception, and autonomous flight enable new possibilities for logistics. Elroy Air is developing an autonomous, vertical takeoff and landing aircraft transporting 200 to 500 pounds of cargo over a 300-mile range by air. Elroy Air is a small team of experts in aerospace, UAVs, industrial design, supply chain, and robotics. We have designed a complete aircraft and cargo solution and have already built working prototypes of our cargo handling, ground navigation systems, and subscale aircraft. Elroy Air's system brings new flexibility to express logistics, enabling rapid aerial delivery of cargo to businesses worldwide.
Been a long, slow slog in terms of commercial drone deliveries here in the U.S. going mainstream. Break down this program, this partnership with UPS for us, and why healthcare seems to be, at least at this point in time, potentially the way forward.
It starts with a need. There's a very big need to make healthcare transportation more efficient. So when you look at a hospital system like Stanford, for instance, where I am today, there's typically 5 to 10 facilities that need to be connected for super fast, super reliable transportation. And that's what our system can do. It can avoid roadway delays. It can give very predictable transportation, shrink the transportation time from like 2 hours down to a few minutes. This is all happening under the auspices of a new FAA program called the Integration Pilot Program for Unmanned Aerial Systems. It started in November 2017, and we're midway through it, and it gives us this opportunity to prove out the technology and figure out how it's going to scale. So we're starting at WakeMed with UPS, and we hope within the next couple of years we can take it to many, many hospitals around the country.
Now, I know from a UPS standpoint, they see healthcare as a big area of growth, big opportunities there. How do you see it? Because in addition to this partnership with UPS here in the U.S., healthcare seems to be an area where you've been launching deliveries in other parts of the world as well.
Yeah, that's right. So Matternet has been operating in Switzerland for over a year and a half now. We've conducted over 3,000 flights over densely populated areas, over the cities of Zurich and Bern and Lugano, with our partners there, Swiss Post. And the opportunity in healthcare is massive. I came across a study a couple of years ago mentioning that the amount of waste in healthcare in the US every year amounts to $750 billion. So $750 billion of waste in healthcare every year in the US. And waste means capacity that is underutilized. In what we're doing with UPS, for instance, we're starting with looking at labs. Can we centralize lab operations to make them way more efficient? And we believe that we can save an average hospital system between $2 and $5 million per year in lab operations alone. And then we expand from there in bringing medicine to bringing savings in how they stock medicine and how they run their pharmacies and so forth. So the implications for how hospital systems can be run from a cost perspective are, I think, tremendous, and we can have very strong positive impact there. Beyond the cost savings, I think we can use this type of system to massively improve healthcare in the country. So imagine when you have to get that lab result back, how crucial it is to get it on time. And with a system like this, we can deliver these lab results, first of all, the samples and then the results much faster than we can do it with the traditional transportation methods today.
Andreas, in terms of location, delivery locations, what is the sweet spot? When is this really going to matter in terms of medicine getting to people or organizations? Is it U.S.? Is it somewhere in the middle of nowhere?
We believe that there's massive benefit in our urban and suburban areas, right? So in a place like the Silicon Valley or WakeMed, where we with our first customer, WakeMed Health, there's a lot of friction on the road, right? If you want to get from A to B, today, in order to transport that blood sample on demand, it takes anywhere between 2 and 4 hours, depending on location. With our system, it can be 15 to 20 minutes, and it's very, very predictable. And if you can imagine this happening many times a day across many facilities, it amounts to a big benefit. So we believe that as urbanization is growing throughout the U.S. and much of the developed world, we need to figure out better ways to transport things on demand. And drone delivery is enabling us to do that in a very, very predictable way. Has many other benefits as well. So it's lower cost eventually, it's much lower ecological footprint. And again, for healthcare, it really matters that we can deliver a blood sample or a pathology specimen in a very, very predictable amount of time. So you know that the lab sample is going to be there in 5.5 minutes, right? And you have plus or minus of a few seconds. Compare that to maybe between 1 and 3 hours.
Along those lines, what about air traffic when it comes to drones? Because Amazon wants to deliver soccer cleats and toothpaste while you're delivering blood samples. Has the technology been figured out well enough to make sure that the right drones, the right items, get priority when the sky starts going dark with drone traffic?
Yeah, that's an absolutely critical question. So the whole concept of the FAA program that we're part of is to figure answers to these types of questions out. There is a construct that has been proposed by NASA a few years ago. It's called Unmanned Aerial Systems Traffic Management, and it tries to figure out how the airspace is going to work. That's why these types of operations are so important. So again, last week we started the first ongoing operation. It's not part of a pilot, it's not a test, it's an ongoing operation. And this type of operation gives the FAA data to understand how airspace is going to work. We occupy the lower part of the airspace, below 400 feet. There's usually helicopter traffic in and out of the places that we fly off because we're flying in and out of hospitals. The reason why we've been able to operate successfully in Switzerland and now bring this operation here in the US is because we have figured out a way to do this safely and deconflict with other users of the airspace. Now, how does this scale? What are going to be the technology components that are needed for this to scale? Is one of the key questions that the FAA is trying to figure out, and we're trying to figure it out with them and much of the rest ecosystem in the drone delivery space as well. And one of the key differences when you compare our system with Amazon is that we fly between fixed locations on fixed routes. So the level of complexity is much lower than if one was flying through somebody's home.
Liftoff.
Also doch knapp.
The urban air mobility market is in a bit of a chicken and egg situation. It's great we may have the technology to give us the aircraft that we need, but where are they going to land? With me now is Duncan Walker, the Managing Director of Skyports. Duncan, welcome to the programme. Now, your organisation is looking very much at the infrastructure that we need to set around this market. How's it going, and what's the challenges that will face the OEMs?
Yeah, thanks, Alan. It's going okay. It's a little tricky because there's no regulation, there's no clear path to market, it's not clear which countries are going to be the first movers. So there's sort of a lot of moving parts which haven't yet been solved. Within that, it's a lot of opportunity, but of course there's a lot of challenges. At some point you just want to know what the answer is rather than constantly be searching the answer. So what we try and do is partner with consortiums of people to really go and offer an entire solution to a city. So in Singapore, we're working with Volocopter. You've got the vehicles. We're going to provide the infrastructure. You've got a really supportive local authority and government, set of ministries and aviation authority. So it's a real balance because infrastructure is a big ticket item. It's long lead time, but unless you're looking at that now, you're not flying in 2023 because you've got nowhere to go.
So for those people that are saying 2023, when do they need to actually start building the infrastructure?
Building sort of 2021, 2022, but to get to the point of building is actually relatively easy. To get to the point of building, you need a long lead time, you need certification, you need electrification, you need planning permission, you need all sorts of other local authority consents. And that could be a 2-3 year lead time. So, we've been looking at this for a couple of years now, we made great progress, but it's not an environment where you can say, right, I need a vertiport here tomorrow. There is a long, long run up to that situation.
And how big are these? How big are these airports going to be?
So big variety. It's very capital intensive to build airports, and until you've got that high volume market, there's no point going and building something the equivalent of Heathrow if you've only got 5 flights landing a day. So there's the physical size, but there's also how sophisticated it is. And it's great for the public perception and get people interested. So these huge sort of monolithic airports with 10,000 landings a day. The reality is you start much smaller and you grow the infrastructure alongside the market as it develops. So you can go for anything from, in smallest sense, is a heliport, a helicopter landing pad, and then you can grow beyond there. What we look at particularly is how scalable these things are. So we might, day one, have quite a limited vertiport with small passenger handling, maybe 1 or 2 landing pads, but we want to be able to scale that so we can evolve with the market.
Now, we know with traditional air transport, introducing an airport is a nightmare with public acceptance. How do you see that bit going? How do you get over the public antipathy towards airports?
Yeah, so I think that's a really good question. What we do is work in a lot of jurisdictions around the world, and we're very sensitive in the UK and we work in the US. The public perception is a hot topic, and there's a huge public voice, and they really do have a sort of bit of leverage to make these things happen or not. We also spend a lot of time in Singapore and other Asian markets where there is much less involvement of the public because of the political regime, and actually they're kind of good for adopting new technology. What you also find is the public in those environments are used to new technology and they're very good at early adopters of those things. The risk appetite might be a little higher, they might be more accepting of these things. So my view is that you might have some relatively unnatural first mover markets. It might be Bangkok in Thailand, it could be Singapore. And once you see the benefits that can bring to a city, and you've got real data points, real proof points, then you start translating it into London or other American cities.
Brilliant. Duncan, thank you very much.
Thank you so much.